Okay, good afternoon once again. Now we'll start, but not all the students have joined, but we'll start. Screen is visible? Hello?
Yes, ma'am, it's visible.
Okay. So in the last class, we have discussed about that exact latch with NAND gate and NOR gate. So have you understood this truth table of SR latch with NAND gate and NOR gate? Have you understood? Because based on this, we will discuss other flip-flops. So can you tell me, have you understood this latch with NOR gates and latch with NAND gates? Soumya? Soumya,
Yes, ma'am.
have you understood this function table?
No, ma'am.
Anyone who can explain? Manas? Manas Biswal? Are you there? Sachin? Sachin, are you there? Please present. Yes. Abhijit Anand. Hello? Abhijit? Abhijit Anand. Anshuman Patnaik. Why you are not responding? What happened? Anish Kumar. Angana Ghosh. That means these students are absent. Signed in and absent. Diya Kiran. Siddhant Swarup.
Yes, ma'am.
So other I will make they are absent. Okay? Because nobody is responding, that means that they are absent. Only sign in करके वो चले गए. So Siddhant, have you understood? Yes or no? Tell me. Otherwise I will proceed.
No, ma'am, not me.
Okay. So once again I will start from this one. So all of you know about that what is latch and what is flip-flop? Yes or no? Latch and flip-flop. Siddhant, tell me.
Yes.
Latch and flip-flop, what is the difference? That you know? Yes or no? Tell me. You don't know? Respond me whether you know or not.
No, ma'am.
Okay. So who can say Soumya? Do you know what is the difference between latch and flip-flop?
Latch is only this set and reset part, and flip flop is the complete control input part.
This is not the proper answer. You can say that latch is SR latch and SR flip-flop is that. But difference is that is the clocked signal is included in case of flip-flop, which is controlled the output. Okay. And in SR the latch cases without your clocked signal. So what is the difference between this one and which is advantageous? Flip-flop is advantageous than latch. Why? Because in latch, if they are changing the input, then automatically the output will be changing. So in that cases, we cannot consider at a particular time what should be the output. If I need 0, but maybe it can be changes to 1. If the input changes, then output is automatically changes. But in case of your flip-flop, suppose this much time I have given. So during this much of time, your output should be 0 or 1. So that's why that will be totally controlled. Okay. So first we should know about the truth table of the latch, then we will apply to the flip-flop. So in the SR latch cases, we have discussed this truth table, and here it is telling that either we can put by the NOR gate or put by the NAND gate. So what is the NOR gate, your truth table, NOR truth table? When both are 0, 0, NOR, output is?
1.
Hello?
Yes, ma'am, 1.
Okay. So this is the NOR gate and this is the NOR gate. So first we know that what is the NOR truth table. And here two inputs are there. One is state, another is the reset. Because we want the content of that memory, either it should be state, means 1, or 0, that means reset. So to do that one, we will use two inputs. One is S or is R. Then now we are just taking the truth table that if one of the input of the NOR gate is 1, you can check from here. Any one of the input of the NOR gate is 1, then output is 0. So you just assume that the first condition is this one is 1 and this one is 0. So then this one is cross coupled, means output of this one is fed to the input. I don't know what is my output here. So we can tell that if this NOR gate, any of the input is 1, so output should be? Output is?
0.
0. So this output that now I know. Then this output is fed to the input of the second NOR gate. So in this NOR gate, here the input is 0. So if both the input of the NOR gate is 0, 0, then what is the output?
1.
1. And now we can say that the state of your latch is, state of the latch is, state is means which state, मतलब उसका कंटेंट क्या है लैच का. हम लोग लैच क्यों बोलते हैं, मतलब एक कंटेंट को वो लैच कर देगा, उसी को वो कंटेंट को वो लैच करके रखेगा till the input are not changes. तो यहाँ पे आउटपुट मेरा क्या आया, आउटपुट क्या है बोलो.
Q के लिए 1, Q डैश के लिए 0.
हाँ, तो एक्चुअली आउटपुट मेरा क्या है, Q है. ओके, बिकॉज इट इज ए 1 बिट स्टोरेज में, मतलब सिर्फ 1 बिट को स्टोर करेगा. तो कौन सा बिट, दैट इज द Q. एंड व्हाट इज Q डैश? Q डैश इज जस्ट कॉम्प्लीमेंट ऑफ द Q. But if somebody is asking that what is the state of this latch, then you can say that the output is 1. So in which condition? If the set value is 1, reset value is 0, then output is 1. Okay? And we have to check that Q that should be complementing each other. यहाँ पे देखो, this is 1, this is 0, so this is 1, 0. Okay, first condition. Have you understood? First one. Have you understood? Have you understood?
Yes, ma'am.
Then now with this output means this one is 1 and this one is 0. With this output, now we are changing the input. 1 0 से अभी हम इसको 0 0 कर देंगे, तो क्या होगा? कहीं से भी तुम स्टार्ट कर सकते हो. ये मेरा 1 है, ये मेरा 0 है. कहीं से भी स्टार्ट कर सकते हो. मैं यहीं से स्टार्ट कर सकती हूँ, नहीं तो यहीं से स्टार्ट कर सकती हूँ. ओके, बिकॉज one of the input are giving and two outputs are giving and this output is set as the input, तो मैं इसको भी कंसीडर कर सकती हूँ. तो यहाँ पे देखो, अगर मैं यहाँ पे कंसीडर करती हूँ, 1 आएगा, यहाँ पे 1 0, तो आउटपुट क्या आएगा? ये 1 है, ये वो 0 है, तो इसका आउटपुट क्या आएगा? 1 0 का आउटपुट क्या आएगा? 0 आएगा. अभी ये 0 जो आया, ये तुम्हारा यहाँ पे जाएगा, तो यहाँ पे तुम ऑलरेडी 0 दिए हो, तो 0 0 यहाँ पे क्या आएगा? 0 0 पे क्या आएगा? 1 आएगा. तो पहले तुमने अज्यूम क्या किया था? पहले हमारा आउटपुट क्या था? 1 0 था. देखो यहाँ पे क्या था? क्या मेरा आउटपुट? 1 0, मतलब Q Q dash, actually Q, but if I'm considering as Q Q dash, so Q Q dash value was 1 0. And now when the input is changes from 1 0 to 0 0, what is the recent output? What?
1 0.
1 0. मतलब तुम्हारा Q में अगर प्रीवियसली 1 रहा होगा, अगर मैं इनपुट 0 0 दूं, तो नेक्स्ट मेरा क्या आएगा? Q का आउटपुट क्या आएगा? बोलो.
1.
अगर उसमें पहले 1 है, तो अभी अगर मैं इनपुट दूंगी 0 0, तो मेरा आउटपुट भी वही 0 आएगा. मतलब there is no change. Okay, like this. Now you start from here. If R is 1 and S is 0, second condition. If R is 1, S is 0, we can check that one. If any of the input is 1, then this NOR gate output should be 0, we know. And this 0 is fed here. Then this both are should be 0 0. This one is 1. अभी आउटपुट क्या हो गया? 0 1 हो गया. Here it is written 0 1. That means Q output is 0. So we can take that if the reset value is 1, then Q value is reset. That means Q value is 0. With this condition मतलब अभी देखो आउटपुट मेरा आया है 0 1 आया. With this condition, if I will change the reset value to 1 to 0, मैं फिर अभी 0 0 दूं, तो क्या आएगा? You can check that part. Again it will be coming 0 1. देखो यहाँ पे 0 1 के बाद 0 0 अगर देती हूँ, तो वो आता है 0 1. मतलब there is no change. So if whatever may be the value of the output, if the input is 0 0, then that value will remain as it is. So 0 0 condition is taken as per the memory concept. Okay. And if the value changes to 1 and 1, then what happens? You can take any of the output. So as we know that any of the input of the NOR gate is 1, then output is 0. So ये 0 आएगा. This 0 is fed here. इसका input भी 1 है, because we have taken the both the inputs are 1 1. ये 0 1 का आउटपुट भी तुम्हारा फिर से 0 आएगा. तो Q Q dash तुम्हारा क्या आया? Q Q dash क्या आया?
0 0.
So actually Q Q dash should be
0 1.
0 1. मतलब कॉम्प्लीमेंट आना चाहिए. तो ये जो 0 0 हो जा रहा है, that's why this is not valid condition, or we can say that this is a forbidden condition. So generally we are preferring that 0 0 0 1 1 0. 0 0 में नो स्टेट चेंज, 0 1 मतलब अगर सेट को 1 करेंगे आर को 0 करेंगे तो आउटपुट हो जाएगा 1. अगर सेट को 0 आर को 1 करेंगे तो आउटपुट हो जाएगा 0, और सेट को 1 करेंगे आउटपुट को 0 करेंगे आर को तो वो हो जाएगा 0. मतलब सेट को एक्टिवेट करने में सेट होता है, रिसेट को एक्टिवेट करने में रिसेट होता है. दिस इज द कंसेप्ट यू हैव टू रिमेंबर. ओके, एंड वन मोर कंडीशन देने में वो इनवैलिड स्टेट होता है. दिस वन इज अप्लाइड टू द NAND गेट ऑल्सो. But thing is that here in this truth table you can check that one when the condition is 1 0 हमारा Q वैल्यू क्या आता था? अगर स्टेट वैल्यू 1 करते तो Q क्या आता था?
0 1.
अरे सेट को एक्टिवेट करोगे, सेट को 1 करोगे तो Q क्या आएगा?
0.
Q 0 आएगा. देखो
NAND गेट नॉर में पूछ रहे हैं आप.
हाँ, नॉर में पूछ रही हूँ. नॉर में
उसमें
पूछ
1
रही
आए.
हूँ कि अगर हाँ एक्चुअली हमारा कॉन्सेप्ट है कि सेट को एक्टिवेट करने से हमारा 1 आएगा, रिसेट को एक्टिवेट करने से हमारा रिसेट होगा मतलब 0 आएगा. लेकिन यहाँ पे देखो सेट को एक्टिवेट करने में आउटपुट क्या आ रहा है?
0.
ओके, और तुम कौन सी कंडीशन में हमारा नो स्टेट चेंज हो रहा था? कौन से कंडीशन में? कौन से इनपुट में हमारा आउटपुट चेंज नहीं होता है?
0 0.
नॉर गेट के लिए.
हाँ, नॉर गेट, सब नॉर गेट के लिए भी पूछ रही हूँ.
0
0
0.
0.
0 0, लेकिन यहाँ पे देखो 1 0 में इसका 0 1 आया और 1 1 में वही 0 1 रिमेन रहा. तो मतलब इसका लॉजिक जस्ट क्या है? ऑपोजिट टू द नॉर गेट है कि नहीं? इसका लॉजिक मतलब हम इसको बोल सकते हैं एक्टिव लो. एक्टिव लो मीन्स देखो अगर मेरा एनी इनपुट 0 होता है तो वही एक्टिवेट होता है. तो आर अगर 0 हुआ तो क्यू मेरा 0 आया. और व्हेन बोथ आर 0 0 मतलब दोनों एक्टिवेट हुआ तभी मेरा नो स्टेट चेंज. फिर एस एक्टिवेट हुआ. कैसे एक्टिवेट? तब हो रहा था 1 में एक्टिवेट हो रहा था, यहाँ पे 0 पे एक्टिवेट हो रहा है. जब एस 0 हो रहा है तभी मेरा क्यू वैल्यू 1 आ रहा है. तो इसको बोलते हैं नेगेटिव लॉजिक. देखो ये देखो डायग्राम कैसा है, इसका डायग्राम कैसा है. जो कंसेप्ट हम लोग ने अभी पढ़े मतलब वट एवर टिल नाउ वी हैव स्टडी दैट इज फॉर द पॉजिटिव लॉजिक. मतलब नॉर्मली 0 0 में नो चेंज होगा, 1 में तुम्हारा 1 आएगा एंड रिसेट वैल्यू 0 में तुम्हारा 0 होगा. बट दिस वन इज जस्ट कॉम्प्लीमेंटिंग दैट वन. दैट्स व्हाई either we can use the negative logic or you can use R S dash and R dash the both the inputs. अगर इसको हम S dash R dash ले जाएंगे तो ये मेरा कॉन्सेप्ट मतलब क्या हो जाएगा? जस्ट लाइक योर नॉर गेट का कॉन्सेप्ट हो जाएगा. तो इन सम बुक इट इज रिटेन S dash R dash. अदरवाइज इफ यू आर टेकिंग S R तो ये नेगेटिव लॉजिक के ऊपर काम करेगा. मतलब 0 0 देने में जो नो स्टेट होता है ये 1 1 देने में नो स्टेट चेंज होता है. अब यू क्लियर? हेलो?
Yes ma'am.
Okay. Now that is a latch with control input. That means this entire thing, this one is your latch, this one is also your latch. But now this latch, whatever the latch, that will be included with another input that is the enable signal, or we can say that clock signal. So how this clock signal is applied to the latch? This is the structure. कैसे होगा? और एक जो enable signal वो to a NAND gate the input is given. Okay, and this enable input to another NAND gate this input is given. So in that latch we have taken, this is the NAND latch, so we are assuming that this one is S dash or this one is R dash. Okay, and now the SR. This is the SR flip flop, and this is the SR is the main input. Okay, but यहाँ पे जो आउटपुट आएगा ये आउटपुट किसके ऊपर डिपेंड करता है, ये नैंड गेट के ऊपर या ये नैंड गेट के ऊपर, एस डैश के नैंड गेट के ऊपर या फिर एस नैंड गेट के ऊपर, ये क्यू आउटपुट. हेलो, क्यू आउटपुट इज डिपेंड अपॉन एस डैश नैंड गेट और एस नैंड गेट.
एस एस का ऊपर ना, इनपुट वहां से आ रहा है.
हाँ, इनपुट वहां से आ रहा है, लेकिन ये जो चेंज होगा ये इसी इनपुट के ऊपर चेंज होगा.
हाँ.
होगा कि नहीं, क्योंकि दिस क्यू इज द आउटपुट ऑफ दिस वन, and unless until this output we are getting, we cannot also process this NAND gate. So first we have to check that what is the input here due to this external input and the enable signal. Have you understood or not? तुम लोग को पता है ये NAND gate जो ये लैच कैसे काम करेगा, इसका इनपुट 0 होने से क्या आएगा, 0 1 होने से क्या आएगा, 1 0 होने से क्या आएगा, 1 1 होने से क्या आएगा. You know this one, yes or no? Yes or no? From the previous truth table, you know that if the input of these two NAND gate is anything, then what is Q dash? You know or not? Tell me.
Yes, ma'am.
हेलो, हाँ, तो अभी नया थिंग क्या है, नया चीज क्या है यहाँ पे, S and En is applied to S dash. So we should know that what is the relationship of S dash with S. तो पहले S देने में S dash चेंज होगा, S dash चेंज होने में तुम्हारा Q चेंज होगा. ये सुनो. हेलो.
Yes, ma'am.
So here we have to find out the relationship of this input with these inputs. Okay, because we can tell that if this input changes, then this input changes like this, and if this input changes, then according to the truth table of the NAND latch, we can find out the output of the QTDS. So for that cases, we should know that the output of this first NAND gate. तो ये तो लास्ट क्लास में हमने की थी. एस डैश इज इक्वल टू व्हाट इज द रिलेशन, एस डैश इज इक्वल टू एस डॉट ई एन बार, मतलब नाम ऑफ ई एंड एस एन. चलो, एस एंड ई एन होल बार, दैट इज इक्वल टू योर एस बार प्लस ई एन बार. हैव यू अंडरस्टूड दिस लाइन? हैव यू अंडरस्टूड दिस लाइन?
Yes, ma'am.
Then R bar कैसा आएगा? Accordingly, this is the concept of R bar plus En bar. Yes or no?
Yes, ma'am.
Yes or no? According to the De Morgan's law, we are putting that. So first, when En is 0, ये क्या हो जाएगा? ये क्या होगा?
1 हो जाएगा.
ये हाँ,
En 0 रहेगा तो En dash 1 होगा ना.
वेरी गुड. तो ये तुम्हारा 1 हो जाएगा, ये भी तुम्हारा 1 हो जाएगा. Okay. So what is S dash? Whatever may be the value of S and R, but this entire value will be 1 because 1 plus something is 1. So यहाँ पे क्या आ जाएगा? जब ये 0 होगा तो यहाँ पे 1 आ जाएगा, यहाँ पे भी 1 आ जाएगा. आएगा कि नहीं?
हाँ.
तो अभी हम लोग जो लैच में पढ़े थे, जब बोथ आर 1 1 तो क्या होता है?
0 1.
0 1 नहीं, नो चेंज. प्रीवियसली 0 1 था, इसीलिए 0 1. अगर प्रीवियसली 1 0 होता है, अभी भी तुम्हारा 1 0, सो दैट इज नो चेंज. तो इसीलिए when the input or EN is 0, whatever may be the value of SR, output is no change. Have you understood? Have you understood?
Yes, ma'am.
Now, when the EN is 1, जब EN 1 हो जाएगा तो EN बार क्या हो जाएगा? 0. ये भी हो जाएगा 0. हो जाएगा कि नहीं? जब 0 हो जाएगा तो S dash is equal to
S dash का वैल्यू
हाँ S dash वैल्यू क्या आएगा?
S0 R0 है तो S का डैश 1 हो जाएगा, R का डैश 1 हो जाएगा, टोटल
हाँ
1 ही रहेगा।
मतलब S dash हाँ मतलब S dash क्या होगा? S बार एंड R dash हो जाएगा R बार, हो जाएगा कि नहीं?
हाँ।
तो ये तो 0 हो गया ना, ये पार्ट 0 हो गया तो ये पार्ट 0 हो गया, तो S dash is equal to S bar हो जाएगा, R dash is equal to R bar. Okay. Now we are giving the input to this S, not S dash. तो अगर मैं S और R को 0 0 करूं, यहाँ पे 0 यहाँ पे 0 करूं, तो S dash R dash क्या आएगा?
1 1
1 1. तो 1 1 में मेरा क्या होता है? One one में
no
क्या
change,
है?
no change, no change,
No change.
no change.
So that's why it will be remain as it is, no change. अभी with EN 1, अभी अगर 0 1 होगा, मतलब S 0 है, R 1 है, तो S dash क्या आएगा? S dash आएगा 1 0. आएगा कि नहीं?
हाँ।
तो S 1 0 है तो क्या आया था? देखो 1 0 में मेरा क्या आया था? 1 0 कंडीशन में मेरा Q क्या आता है?
0 1
0 1. देखो 1 0 कंडीशन में जब S मैंने 1 0 दिया तब मेरा आउटपुट आया Q 0, क्योंकि S dash R dash आ गया मेरा ये क्या है 1 0 आ गया. तुम इनपुट यहाँ पे दे रहे हो 0 1, तुम यहाँ पे दे रहे हो, ये 0 दिए ये 1 दिए, बट ये हो गया 1 ये हो गया 0, तो फाइनली मेरा आया Q 0. मतलब S को जब तुमने एक्टिव किया तो आउटपुट आया Q 0. फिर जब S को 1 दिए R को 0 दिए तब ये क्या हो जाएगा? ये 0 हो जाएगा, ये 1 हो जाएगा. तो S 0 मतलब तुम्हारा आउटपुट तुम्हारा क्या होता है? 1 होता है अकॉर्डिंग टू द लैच. तो ये हो गया तुम्हारा सेट कंडीशन. एंड व्हेन बोथ आर गिविंग अस 1 1, ये दोनों को 1 1 दोगे तो इसमें क्या आएगा? इसमें क्या आएगा?
0
0 0. तो 0 0 में क्या होता था हमारा? देखो 0 0 में क्या आता था?
forbidden.
Forbidden. So that forbidden or invalid or indeterminate all are same. That means that is not the valid condition. So same thing, whatever may be the truth table of this latch, same thing the truth table of your flip-flop. Only the difference is that enable line is 0, enable line is 1. That means depending upon the enable, this output will change. But here, if the input changes, output changes. Have you understood the difference between latch and flip-flop? Understood?
Yes, ma'am.
Hello? Have you understood? Yes or no? Tell me. Okay.
Yes, ma'am.
Okay. So with this concept, we will design another latch. Okay, that is the D latch. So D latch हम किसको बोल सकते हैं? We can tell that latch में तुम्हारा clock भी हो सकता है, नहीं भी हो सकता है. अगर clock होगा latch में, so that will be A label trigger. A label trigger means either positive label or negative label. तो हम जो SR flip-flop जो हम SR है उसको भी हम D latch भी बोल सकते हैं. So and this one is known as a transparent latch. Why that will be a transparent latch? Actually it is nothing but just like your SR flip-flop, just like. तो ये जो तुम्हारा SR डायग्राम, SR flip-flop का डायग्राम यहाँ पे है. Have you seen the or compare the diagram of SR with enable input and this diagram, both are same or different? Can you tell me?
Same.
Same. So we can tell that. And यहाँ पे देखो हम लोग क्या है कि अगर एक इनपुट लेते हैं, यहाँ पे देखो ये ट्रूथ टेबल से देखो 0 0 देने में नो चेंज होता है, 1 1 देने में इनडिटर्मिनेट होता है. दैट मीन्स व्हेन द बोथ द इनपुट्स आर 0 0 there will be no change. तब मतलब कुछ इफेक्टिव नहीं होता है. And if the both the inputs are 1 1, then also it will be invalid condition. But if the both the inputs are complementing each other, then the output will be changing as 0 or 1. So to do this one, if we are using a single input instead of two input, तो हम कैसे यूज करेंगे? हम सपोज यहाँ पे 0 देते हैं, ओके? तो यहाँ पे 0 देने में इसको क्या जाएगा? ये है तुम्हारा S, ये है तुम्हारा R. तो ये जाएगा 0 देने में, ये इसको 0 जाएगा, इसको क्या जाएगा? 1 जाएगा. तो ये तुम्हारा SR विद एनेबल इनपुट हो जाएगा. तो S को 0 देने में, R को 1 देने में आउटपुट क्या आता है? देखो यहाँ से देखो, S को 0 देने में कहाँ पे गया? हाँ, ये वाला कंडीशन. ये दोनों कंडीशन हम लोग अभी स्टडी करेंगे. S को 0 देने में, R को 1 देने में आउटपुट क्या आता है?
0.
आउटपुट आएगा 0. एंड जब B को 1 दिए तब S को क्या आएगा? 1 एंड R को आएगा 0. तो आउटपुट आएगा 1. 1. जब S 1 है, आउटपुट R 0 है, तब देखो यहाँ पे S1 आउटपुट में ये S1 R is 0. So Q is 1. Okay. So what it is saying that instead of two input, if only one input I can take, and I will take the condition of SR by including a NOT gate. Then although I am giving the one input, but I will get your two input. So it is just like your SR flip-flop with your enable line. So if the two input are merged to a single input, that one is known as D flip-flop. Okay. And what is the necessity of D flip-flop? This is known as D latch. मतलब whatever the D value, that will be latched. तो D value अभी यहाँ पे देखो, D तुमने जब इनपुट दिए 0, तो आउटपुट क्या आया? 0 है. जब इनपुट 1 दिए तो आउटपुट क्या आया? 1 है. मतलब whatever the data, that should be latched. Okay? मतलब डाटा जो तुम्हारे 0 दे रहे हो वो लैच होके रह रहा है जब तक तुम इनपुट चेंज नहीं कर देते. और why it is known as transparent? Because we are whatever the data we are giving, same output we are getting. So that is totally transparent. जो देते हैं वही मिलता है. Okay. So question is that what is the application of this type of flip-flop? एप्लीकेशन कहाँ पे होगा? जहां पे हमको सिर्फ डाटा तो मुझे चाहिए, सेम डाटा चाहिए आफ्टर सम टाइम. So that time will be provided by this circuit. If the circuit duration is 20 minutes, that means if I am giving any input at here, after 20 minutes I will get the output here. तो हम क्या करेंगे? If suppose at this point I am getting this output, because whenever we are combining or designing any circuit, वो तो सिर्फ एक ही लैच है और एक ही फ्लिप फ्लॉप कोड नहीं है. That is combination of so many flip flops and so many circuits are there. Suppose I want the 0 at this time, and after some time or later I want same 0. But during the meantime I am doing other work. So due to the other work, maybe this output changes to 1. Yes or no? अगर मैं अभी ये आउटपुट को यूज नहीं कर रही हूँ, बाद में यूज करूंगी, तो अगर कोई किसी कारण से तुम्हारा इनपुट चेंज होता है तो आउटपुट भी चेंज होने का चांसेस है कि नहीं? हेलो,
हाँ हाँ
तो अभी मैं वही आउटपुट को एक डी लैच में पुट कर दूंगी। तो डी लैच का इनपुट होगा 0, आउटपुट भी क्या है?
0
0 है। मुझे क्या चाहिए था आउटपुट?
1
मुझे क्या, वही 0 चाहिए था, बट आफ्टर 20 मिनट्स चाहिए था। तो दैट 20 मिनट्स विल बी प्रोवाइडेड बाय द सर्किट। मतलब जो अभी मुझे जो 0 चाहिए, मुझे चाहिए था कि मैं कुछ दूसरा काम करूंगी और 20 मिनट्स के बाद मैं ये आउटपुट को चेक करूंगी। कौन सा? यही आउटपुट को मैं चेक करूंगी। तो वो बोला है कि इफ इट इज सपोज यू आर डूइंग सम अदर वर्क, ड्यू टू एनी रीजन, मे बी दिस आउटपुट चेंजेस टू 1, बट if I will put this output to a D latch, वो 0 जाएगा, फिर यहाँ पे टाइम लगेगा, यहाँ पे टाइम लगेगा, यहाँ पे टाइम लगेगा, यहाँ पे टाइम लगेगा, फिर जाके आउटपुट मिलेगा। तो तुम्हारा जब 20 मिनट का काम, दूसरा काम खत्म हो रहा होगा, तो तुम्हारा आउटपुट क्या होगा? मस्ट बी व्हाट?
0
0। तो आउटपुट तुम्हारा चेंज हुआ
नहीं।
तो तुम एक्चुअली, हम यहाँ पे ये कौन से एप्लीकेशन में करते हैं जहाँ पे हमको आउटपुट को ज्यादा टाइम के लिए स्टोर करके रखना पड़ता है। हम लोग उसको डी लैच में रखेंगे, तो क्या होगा कि मेरा जो भी आया होगा वो चेंज नहीं होगा, लेकिन वो ज्यादा टाइम तक सेम रहेगा। फॉर दैट रीजन वी कैन यूज द डी फ्लिप फ्लॉप, एज वेल एज इंस्टेड ऑफ 2 इनपुट वी विल गेट ओनली 1 इनपुट। 0 देते हैं तो 0, 1 देते हैं तो 1। मतलब only 2 combination we have to take, because single input means 2 combination. But if I'm taking 2 S and R, so 4 combination. Okay, so this is the D flip flop. Next, okay. So next one is, these are SR flip flop. So already we have discussed this one. Instead of your enable line, we can also use the clock. Okay. So either positive is, negative is, or positive label, negative label, we can use the clock pulse in place of enable. Then this is the characteristic table of the SR flip flop. Okay. So what do you mean by characteristic table? So characteristic table मतलब इनपुट क्या देने में तुम्हारा आउटपुट, अगर देखो तुम जब इनपुट देते हो, यू आर एज्यूमिंग सम प्रेजेंट स्टेट इज समथिंग and assuming, listen, you are assuming what is my present state, and after giving the input some next state आता है कि नहीं? एक तो suppose एक तो system का characteristic equation, what is the characteristic equation of a particular system? How can you define that one? Can anybody tell what is the characteristic equation of a particular system? क्या होता है? Hello. Hello. Nobody knows. What is your characteristic? If somebody is asking. That means your output, your response. If I am giving one question, then if you are able to answer that one, that is your knowledge, then I can tell that no, he is a very good student or he is a very bad student. So categorize, like I can tell that if this question, if suppose somebody is asking that this question he can do, then according to your characteristic or according to your knowledge, so I can say that whether you are able to do that one or not that one. So like this, suppose any system is there. So if I am giving the input, then it will change the output of a certain pattern. So that pattern is nothing but the characteristic equation. इस इक्वेशन के बेसिस पे अगर इक्वेशन में हम इनपुट देते हैं तो उसका आउटपुट ये निकलता है. So that equation is known as characteristic equation. Do you agree or not? Hello? Hello?
Yes,
If somebody is saying, it is not audible properly. तो यहाँ पे हम लोग क्या कैरेक्टरिस्टिक टेबल कैसे बनाए? If I am taking QA as the input with S, with R, then what is the Qn plus 1? I will find out that. So, what is Qn? What is Qn plus 1? Qn means for the present state. Qn plus 1 means next state. Matlab, if I am assuming Q is equal to 0, then I am applying the 0, 0 or 1, 0, whatever the input I have applied. Then this Q is changes to 0 or 1. On what basis? On what equation this Q changes to 1? That equation is known as characteristic equation, and the table you will get that is known as characteristic table. Have you understood? Have you understood?
Yes, ma'am.
Okay, so now we will just write the characteristic table. So input of the characteristic table are three input. One is Qn, that means previous state, and new state. Because the combinational circuit के लिए तुमको तीन input देना पड़ेगा. One is the memory output, another is the external input, and with the clock. If you are applying all this, then output will be changing. So, if the three input मतलब क्या क्या कितना combination होगा? कितना combination होगा?
8.
8 combination. You just write all the combination 0, 0, 0, 0, 0, 1. Like this you can write. Why I am not mentioning from here? Because here something it is not coming properly. So that's why I am doing again that two tables. Okay. So then 0, 1, 0. I am not writing all, only explaining one, and you can complete that. Okay. So abhi dekho, how we will find out the Qn plus 1. So tell me that if the previous state is 0 and the input is 0, 0, तो next state क्या आएगा? हम लोग क्या पढ़ेंगे? जब हमारा input 0, 0 होता है तो output क्या आता है?
0.
Output 0 आता है या फिर no change?
No change.
No change. तो अगर Q मेरा 0 है तो output क्या आएगा?
0.
Very good. 0. अभी 0 with 0, 1 हम लोग पढ़े हैं कि 0, 1 कंडीशन में मेरा क्या आता है?
1.
0, 1 कंडीशन में किसको 1 किया गया है? S को या फिर R को? हाँ,
फिर से बोलिए तो क्या बोले?
हाँ, यहाँ पे 0, 0, 1 में हम लोग इनपुट को चेक करेंगे. इनपुट में किसको एक्टिवेट किया गया है? अरे S 0 है, R 1 है, तो कौन सा एक्टिवेट हुआ है? R जब अप्लाई करते, R जब एक्टिवेट होता है तो आउटपुट वो क्या कर देता है?
बदल देता है.
मतलब क्या करता है? रिसेट कर देता है ना. R स्टैंड्स फॉर रिसेट. रिसेट मतलब वो क्या करेगा? 0 कर देगा. तो वट एवर मे बी द प्रीवियस स्टेट, अगर वो 0 है तब भी वो 0 रहेगा, अब अगर वो 1 है तब भी वो 0 रहेगा, बिकॉज R वैल्यू इज 1. गॉट इट? गॉट इट?
यस मैम.
देन अगर मेरा S 1 है, R 0 है, तो आउटपुट क्या आएगा?
1.
वेरी गुड. Whatever may be the previous value of Qn, अगर S 1 है मतलब आउटपुट 1 आएगा. ओके. नेक्स्ट कंडीशन इज 0, 1, 1. नाउ टेल मी 1, 1 है तो क्या आएगा? 1 1 होने से क्या होता है? 1 1 होने से क्या होता है?
फॉरबिडन हो जाएगा।
हाँ, तो इसको हम डोंट केयर करेंगे। ओके, फिर से 1 0 0 1 0 1 1 1 0 एंड 1 1 1। अभी देखो विथ Q1 अगर S एंड R 0 0 है तो Qn+1 क्या आएगा?
1।
वेरी गुड, दिस शुड बी 1। व्हेन 0 1 आउटपुट क्या आएगा? कौन सा 1 है? R1 है या फिर S1 है?
R1 है।
तो आउटपुट क्या आएगा?
0।
वेरी गुड। यहाँ पे S1 है या फिर R1 है? S, तो आउटपुट क्या आएगा? 1।
हाँ।
ओके, देन 1 1 है, फॉरबिडन। गॉट इट? गॉट इट? समझ में आया?
यस मैम।
मतलब इफ यू आर एज्यूमिंग वट एवर मे बी द Qn वैल्यू, मतलब प्रेजेंट स्टेट अगर 0 है, अगर हम इनपुट ये देते हैं तो नेक्स्ट स्टेट मेरा ये आएगा। प्रेजेंट स्टेट ये है, उसके साथ अगर इनपुट ये है तो नेक्स्ट स्टेट मेरा ये आएगा। सो we have to find out the equation for this, and that equation is known as characteristic equation. वो जो कैरेक्टरिस्टिक टेबल मैंने बनाया है, इसको अगर मैं के मैप में डालूंगी तो दिस इज द के मैप एंड दिस इज द इक्वेशन ऑफ दैट के मैप. So this one is known as characteristic equation of SR flip-flop. Have you understood? Have you understood?
Yes, ma'am.
Okay. And is the symbol of the SR flip-flop. This is a box-like structure. Then this is S input. This is R input. This is the clock. And with clock, if a arrow symbol is there, that means it is a positive age clock. मतलब ये arrow symbol होता है age के लिए, because clock should be age triggered or level triggered. If it is arrow symbol is there, then it should be positive age. मतलब इनपुट से आउटपुट कब चेंज होगा? जब 0 से 1 पर एज में क्लॉक का चेंजेस होगा, तब भी तुम्हारा आउटपुट एक्टिव होगा, नहीं तो एक्टिव नहीं होगा. एंड दिस इज द Q and Q dash. So this is the symbol of SR flip-flop. This is the characteristic equation. So characteristic table, this characteristic table is nothing but this table, how I made, and from this one, by applying the K-map, you can get the equation, which is nothing but characteristic equation. Okay. Then only the last one I am explaining, that is excitation table. So have you understood characteristic equation? Matlab, if which type of input we will give so that this type of output, sorry, if suppose the current state is this one and this input I will give, then what will be my next state? So next state मेरे कौन से टेबल से पता चलेगा, वो ही तुम्हारा कैरेक्टरिस्टिक टेबल. ओके. लेकिन एक्साइटेशन टेबल मतलब अगर प्रेजेंट स्टेट मेरा 0 है, अगर नेक्स्ट स्टेट मेरा सेम, मतलब फॉर एग्जांपल मेरा काउंटर में मेरा पहले मेरा 0 1 2 3 4 ऐसा काउंटर है. सो व्हाट शुड बी माय इनपुट so that it will be producing from 0 to 1 1 to 2 2 to 3 like this. Then that table is known as your excitation table. Means what inputs we have to give so that these states are changing. Are you understanding? Hello? Hello?
Yes, ma'am.
Yes, ma'am.
So what is the difference between characteristic table and excitation table? Characteristic table means if all the inputs you are giving, then what will be my output? But in excitation table, this is my present state this is my next step. So what should be your excitation? That means what should be your inputs? For example, here you can look at अगर प्रेजेंट स्टेट 0 है, नेक्स्ट स्टेट 0 कैसे रहेगा? तो एसआर वैल्यू कैसे रहेगा? एसआर वैल्यू प्रेजेंट स्टेट 0 है, नेक्स्ट स्टेट 0 है, तो एसआर क्या होगा?
0.
एसआर 0 होने भी होगा और 1 होने भी से भी होगा, क्योंकि अगर आर भी 1 होता है तब भी मेरा आउटपुट 0 होता है कि नहीं? तो दिस वन इज 0 डोंट केयर, मतलब बोथ 0 होने में भी प्रेजेंट स्टेट 0 है, नेक्स्ट स्टेट 0, मतलब नेक्स्ट स्टेट कौन से कंडीशन में 0 होगा? एक तो ही तुम्हारा जब 0 नो चेंज कंडीशन में होगा, नहीं तो अगर 0 1 इफ द आर वैल्यू इज 1 देन ऑल्सो विल गेट 0. देन अगर प्रेजेंट स्टेट 0 है, 1 कौन सी कंडीशन में आएगा? दैट इज स्पेसिफाइड कंडीशन. कौन सा कंडीशन? वेरी गुड, S1 R0 स्पेसिफाइड कंडीशन. अगर मेरा 1 था अभी 0 आया, कौन से कंडीशन में? जब R को 1 करोगे. ओके, बट अगर 1 था 1 आया तो कौन से कंडीशन में?
1 0 में और 0 0.
हाँ, किसमें?
1 0 और 0 0.
वेरी गुड, वेरी गुड. 1 0 and 0 0. So that's why this is don't care and 0. Okay, so this is the excitation table. This is very important, and this is the characteristic table. You have to take a look. Now I am giving the link of the quiz. We will do that one. Okay, have you got it?
Yes, ma'am.
Okay, do it now. Okay, so you will submit your quiz. So this is for today. So thank you all.
Thank you, ma'am.
Good afternoon, students. Am I audible to you all?
Good afternoon, sir. Yes, sir, you are audible.
Karatsuba, I think we have completed in your class. Karatsuba's algorithm. Is Karatsuba is completed or not?
Yes, sir.
Okay. Yes. Convolution and fast Fourier transform. Okay. So basically, this is a problem from the electronics and communication domain. So I don't expect you all to understand this problem from the point of view of the electronics and communication systems, because you have not been taught signals and systems yet. But nevertheless, we will try to understand what is the inherent computer science problem or inherent problem related to CS, and how this problem can be solved using divide and conquer. Okay, so for that we need to understand what is the meaning of fast Fourier transform, what is the meaning of convolution, how this problem can be represented using our arrays, linked lists, or our things, not signals and not systems. Okay, so we will break this problem from the signal point of view to our array point of view. Okay, and then this problem will become easier for us to solve it. Okay, and once we have broken it into the corresponding problem, then we will see how we can apply divide and conquer to that problem. Okay. Yes, let us understand what is the meaning.
Sir, our screen is not visible.
I have not shared the screen. Just a second. Yes, now it is visible.
Yes, sir.
Yes. Yes, let us understand what is the meaning of Fourier transform. Okay, so if you are not aware of signals and systems, let me just give you a basic understanding of what Fourier transform does. So if I give you a shake and I ask you separate the fruits. If I give you a shake and I ask you to separate the fruits, the vice versa is very easy. I give you banana, apple. ask you to make a shake, that can be done. But if I ask you that given the shake, can you bring back all the fruits? So yes, we can do that. Let us imagine there is a filter and there are 3 different kind of filters. Okay, and once we put this juice through the filter, we will get its constituents back. Okay, so that is what a Fourier transform does. Okay, so basically every data is transmitted from one system to another system through signals. Okay, this signal has to be transmitted from this system to another system. Okay, then the decodings will happen, the encodings will happen, all those things will happen. Okay, but we are now concerned with the signal. Now, if I give you a signal and I ask you, find out all its constituents or find out all its properties. Okay, so what can be the properties? Amplitude, frequency, phase. So all those information can be available if we apply Fourier transform on a signal. Okay, so basically Fourier transform, it takes a time-based pattern. What is a time-based pattern? This is if the time increases in this order, a time-based pattern is nothing but a signal. Okay, or a time-based signal. Now it takes a time-based signal, measures every possible cycle and returns the overall cycle recipe, which are amplitude, offset and rotation speed. Amplitude, offset, frequency, phase, rotation speed, all those information can be got from the signal itself. So I am giving you the shake, I am asking you find all the ingredients. That is the job of your Fourier transform. Okay. Now, before you can understand what is the job of Fourier transform, we need to understand that how a signal is represented. Okay, every signal can either be represented by its frequency domain or by its time domain. Okay, so what is the meaning of time domain and what is the meaning of frequency domain? So when a signal is represented according to the rate of change of time, at time 0, this is the value of signal, at time 1, at time 2, at time 3, so on and so forth. Okay, so if a signal is represented with rate of change of time okay, then such a representation is known as time domain representation. Okay, if I am representing a signal according to its time, rate of change of time, or what is the value of the amplitude at a particular time instance, value of amplitude at a particular time instance, value of amplitude at a particular time instance. Okay, so if I am plotting the amplitude versus the time graph, then it is known as the time domain representation. Okay, and the time domain representation of a graph differs from its frequency domain representation. So in the frequency domain representation, now every signal is either made up of a single frequency or composite frequencies. Okay. Mostly when signals are transmitted, they are transmitted as composite signals. So every signal that is transmitted, mostly, not every, so most signals that are transmitted are mostly composite signals. So composite signals means it will have multiple frequencies. Now, the representation of a signal according to its constituent frequencies is known as its frequency domain representation. Okay, so yes, again in the left axis, in the y-axis, we are taking amplitude, and in the x-axis, here we are taking the different frequencies. Okay, so how much amplitude of which frequency is contained in the signal? So if the amplitude is 5 here, so I will say there is a signal of 5, so of amplitude 5 whose frequency is 2 Hertz, and also there is a signal whose amplitude is suppose 8 and whose frequency is 5 Hertz. Now these two signals are making one composite signal whose representation is this. Okay, so yes, either I can represent a signal using its time domain, or I can represent a signal using its frequency domain. Okay, so either I represent using its time domain or using its frequency domain, the information remains the same. Okay, let us see some examples. A time domain graph shows how a signal changes over time. How a signal changes over time. Okay. Whereas a frequency domain graph shows how much of the signal lies within a particular frequency. Okay. A frequency domain representation can also include information on the phase shift that must be applied to each sinusoid in order to be able to recombine the frequency components to recover the original time signal. So when multiple frequencies are present in a composite signal, they are separated by the phase. That phase information is also available. Okay, so yes. Now, why we are going to study this frequency domain and time domain? We were studying the concept of Fourier transform. So in simple words, Fourier transform converts a signal in time domain to its frequency domain. To its frequency domain. So if I want a signal in the time domain and I want another signal, or I want the same signal to be represented in its frequency domain. So I will take the time domain signal, okay, apply Fourier transform. Once I apply Fourier transform, I will definitely get a frequency domain signal. Okay, so to convert a signal in time domain to its frequency domain, we use Fourier transform. So basically Fourier transform is a mathematical tool that can convert the time domain signal into its frequency domain. Now you will ask the question, why should I go for frequency domain if the signal is already represented in time domain? Most of the digital systems, there is a slide actually, let us go to that slide. Before that, let us see some examples. Okay, so if you see in this example, in the time domain, the signal is occurring more frequently. If the signal is occurring more frequently, its frequency is less or more, or low or high. Yes, this is a high frequent signal. Why? Occurring more frequently. Now let us convert it into its corresponding frequency domain. It is a single signal because it is having a single amplitude. Okay, so it is not a composite signal. So there will be only one frequency, and that frequency, let us call it at 5 Hz. Okay, now if you see the second example, the signal is occurring less frequently. If the signal is occurring less frequently and it has a single amplitude, okay, in that case, can I say that this is also having a single amplitude or single frequency, and that frequency will be less than the above example? Because in the above example, the signal was more frequent, frequency was more. Now the signal has become less frequent, frequency should be less. So this will be something around 1 Hz. Now let us look at the third example. In the third example, there are two basic type of amplitudes. And if you see the higher amplitude pattern or the higher amplitude signal is occurring more frequently, so its frequency should be more, and the lower frequency signal is occurring less frequently, so its frequency will be less. So now if you see the corresponding frequency domain representation, there are two frequencies, one a higher frequency and another is a lower frequency. Okay, so this is how a signal is represented in its time domain and in its frequency domain. Okay, so there is one important thing we need to understand here. Okay, so if you see the first signal, in the first signal, there is only one frequency. Okay, I add that with itself. Now I will get the same frequency. Okay, one same frequency. Okay. Now, if you see the next signal, which we call signal 2, let us add it with our previous signal, which is signal 1. So when a low frequency signal is added to a high frequency signal, this process is actually not addition. Okay, this process is called as convolution. So when two signals are added, they are actually convoluted. Okay, and once the convolution takes place, we will get a composite signal. Okay, so if you see, this signal was added to this signal and this is the resultant signal. Okay, now again to this resultant output we are going to add this signal, okay, which is another low frequency signal. Okay, and this is now the corresponding signal. Okay, so the point here is, when a signal is added to another, a composite signal is formed, and that composite signal is formed through the process of convolution. Okay, so this convolution is the process which will give us a composite signal. Okay, so don't think of it as addition, it is actually convolution. If you see the original signal, there was only one frequency. This was added to this, so we get two frequencies. Okay, this was added to this, now we get three different frequencies. Finally, we had four superimposed frequencies or signals to form this composite signal. Okay, so when we apply Fourier transform, this is what we will get. Four different frequencies of the composite signal. Okay. Yes, this is actually one of the examples which has been actually done in the MATLAB. So this is the given time domain representation. Okay, now I have applied fast Fourier transform. Okay, once you apply fast Fourier transform, the real part and imaginary parts are formed. Okay, some differential filter is applied to smoothen this. Okay, and we get the corresponding real frequency, real part and the imaginary part. Again, that is converted into the corresponding frequencies. So this signal, it had two basic frequencies, so it was converted in the frequency domain. Its graph had two peaks, okay, at two different frequencies. Yes, is the concept of time domain and frequency domain clear? What is the meaning of time domain? What is the meaning of frequency domain? How a signal can be represented in the time domain and how a signal can be represented in the frequency domain? Okay, if you understand it, now we'll move forward to the next concept. It says, why we have the frequency domain representation? We have the time domain representation. Why do we need to go for the frequency domain representation? The point is, one of the main reasons for using a frequency domain representation of a problem is to simplify its mathematical analysis. Okay. Now, if I am given a yes, if I am given a time domain representation, which is a continuous graph. Okay. Now, is this analyzing this more difficult, or is analyzing this more difficult? Whereas in this, you will get all the information available here and also extra information, such as the phase and the angle at which they are separated from each other. Okay, so you'll get that information also. Why would I go for this complex representation, and why would not for the simple representation? Okay, so simplicity of mathematical analysis is the foremost reason why the frequency domain representation is preferred. Okay, because nobody wants to do complex analysis. Everybody wants a simple graph that can be represented using just the frequency domain. So that is the reason most of the digital communication that takes place, even your television communications nowadays, they are using a digital mode of communication. Okay, and most of the digital communication deals with frequency domain representation. Okay, they do not deal with the time domain representation. All those sounds, all those videos, all those images, all those texts that you are sending, they are converted into their corresponding frequency domain. And once they are converted into their corresponding frequency domain, now they are transmitted through a network, and it is this objective of the system to now decode the signal. Once the signal is decoded, and only then you can understand what the corresponding frequencies were. But if you send the frequency domain altogether, you don't need decoding of the signal, because the frequency domain itself will contain a lot of information, and that information is sufficient to process the signal. Okay. Now the second advantage is using your time domain. Since they are continuous domains, all those answers will be in the form of integrals. Okay. But when you deal with a frequency domain, these are called differential equations, if you would have studied. Okay. And if you represent a signal using its frequency domain, then all the calculations will be in the form of algebraic equations. Now, is solving a differential equation easy, or is solving an algebraic equation easy? Of course, solving an algebraic equation is easy because the differential equations are in continuous domain, whereas these algebraic equations, they can represent the discrete domain. And in digital communications, we are mostly concerned with the discrete domain. Okay. Yes, these are the mathematical definitions of how you can convert to its corresponding frequency and t. In time f of t, we can find its frequency domain just by applying the Fourier transform. Okay. Once you apply the Fourier transform, you will get the frequency domain representation. Yes. And if you are given the frequency domain and you want to find the time domain, the concept is inverse Fourier transform. Yes. Given the frequency domain, you can convert it into the time domain. Just you have to apply the inverse Fourier transform. Okay. So these are the mathematical notations of denoting Fourier transform and inverse Fourier transform. Okay. Now, until now, we have understood what is the meaning of convolution. The convolution process, actually, it adds two signals pointwise so that a corresponding composite signal is formed. Okay. So let us understand what the convolution theorem is saying. Yes. Now the convolution theorem is saying that if I want to find if there is a composite signal, what is the meaning of composite signal? It means more than one frequency. Okay, if there is a composite signal and if it has more than one frequency. If it is a composite signal, we have already discussed, let signal 1 be denoted as A. Let signal 2 be denoted as B. If this is a composite signal, it must have been formed by convolution, because only convolution can form composite signals. Now, if this signal was formed by convolution, then now we know that there is a composite signal. A is one component, B is one component, and this is the convolution. Now, somebody asks you, convert the above signal to frequency domain. Yes, what is the tool to convert a signal in its time domain to frequency domain? That is Fourier transform. Okay, so now I have to apply Fourier transform of A convolution B. Yes, this convolution operation, as we will see, will take n square steps. Okay, so since this will take n square steps, now we want a shortcut for this. Okay, so the shortcut is that Fourier transform of a convoluted signal is equal to Fourier transform of the first signal pairwise multiplied with the Fourier transform of the second signal. I repeat again, Fourier transform of a convoluted signal is equal to Fourier transform of the first signal into the Fourier transform of the second signal. This is not convolution, this is pairwise multiplication. Okay, now this is pairwise multiplication. What does this mean? That means, let us see how a signal is represented. A signal is basically a sequence of points. We are saying a time signal or a time domain signal. A time domain signal contains amplitude Suppose this is the time domain signal. Now this time domain signal, it is nothing but it is an array of bits. Yes. Now this array of bits will be multiplied with another array of bits, which is B. Okay. Now this will be multiplied with this. This will again be multiplied with this. So I just show it here. There is one array here, one array here. This element will be multiplied with every other element. Again, the second element will be multiplied with every other element. The third element will be multiplied with every other element. Okay, so this will go on since the process of convolution will take place. Okay, so in order to reduce that, what we can do, we can find the Fourier transform of A and pairwise multiply it with Fourier transform of B. Okay, because the convolution theorem is saying this is equal to Fourier transform of A convolution B. Okay. That is your convolution theorem. In mathematics, the convolution theorem states that under suitable conditions, the Fourier transform of a convolution of two functions or signals, Fourier transform of convolution of two signals, okay, is the pointwise product of their Fourier transforms. Okay, Fourier transform of a convolution of two signals is equal to Fourier transform of their individual signals multiplied. Okay. Now we have understood that the signal is represented as a set of points. Okay, this is my A. Similarly, B is also represented as a set of numbers, or these are bits. Okay, how the signal will be represented? At time 0, the value is 1. At time 2, the value is 0. At time 3, the value is again 1. Then there is a 0. Okay, then there is a 1. Then there is a 0. Then there is a 1. This is how the signal A is going. Similarly, for B, we can draw. They're becoming the same, na? Okay, no issues. The first point is bigger. Okay. Just a second. Yes. At time 1, the signal is having amplitude 1. At time 2, let this amplitude is again 1. Okay. At time 3, it is again 1. At time 4, it is 0. Okay. So this is how the signal is represented. But nevertheless, we can represent it from our point of view using arrays. Okay. So now our problem has been broken down from the concept of signals into multiplication of two arrays. Okay. So multiplication of two arrays, if you take the first element and multiply it with every other element. Yes. Again take this element, multiply it with every other element. So one pointer has to be run here, another pointer has to be run here. Okay. This will be called my I pointer. This will be called my J pointer. Definitely the running time will be order of n square. Okay. Why? Because this is the formula for your convolution. Convolution says that every Ck is equal to Ai Bj such that I plus j is equal to k. Okay. And I and j are less than n. So now if we want to visualize how the array will look, this is how the array will look. Yes, the first element will be A0, B0, A0, B1, A0, Bn minus 2. So this A0 will be multiplied with all elements. A1 will be multiplied with all elements of B. A2 will be multiplied with all elements of B again. Okay. So for B, we have to run a n-1 loop. For A, we have to run a n-1 loop. So definitely the time complexity here will be n squared. Okay. So what is the definition of convolution? The definition of convolution says that we are going to pairwise multiply. We are going to pairwise multiply two signals, A and B. Okay. Now our problem has been defined. We have a array A which starts from A0 until A n minus 1. Okay, we have an array which starts from B0 until Bn minus 1. We have to multiply these two, so we will get an array which will start from C0 until C 2n minus 2. Okay, why? This is the maximum degree, and maximum degree, okay, of the solution that will be formed. But if you see, again, we are stuck with the problem of n square time. And we have seen until now, wherever we have got the n square time, we have used the concept of divide and conquer. Okay. So here also, we have to somehow apply the divide and conquer strategy so that we can reduce the time complexity from n square to something like order of n log n. Okay. So that is the concept of designing a order of n log n algorithm. Okay, so yes, until now we know we have a time signal, apply fast Fourier transform. This will give us the frequency signal. Again, to break this problem further, we know that every composite signal is a convolution. That the Fourier transform of it is equal to the Fourier transform of A multiplied with Fourier transform of B. Okay. Now, if it is to be multiplied, we have to reduce the time complexity from order of n square. For that, we need a divide and conquer approach. Okay. So that divide and conquer approach can give us order of log n time. Okay. Now to find the solution, what we are going to do is we are going to represent our set of points represent them as polynomials. Okay. Now, if I represent them as polynomials, now let us represent them as polynomials. A of x is equal to a0 plus a1x plus a2x square plus dot 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 a n minus 1 x to the power n minus 1. Okay. Now, similarly, I will divide b0, b1x, b2x square, b n minus 1 x n minus 1. Okay. So now I have represented the set of bits or the signal itself as two polynomials. Okay. Once I have represented them as two polynomials, now I have already found out that the convolution of these two is equal to the convolution of this into the convolution of this. So my problem is now reduced to multiplication of two polynomials. Okay. So if it is now the convolution of two polynomials, okay, again you will see I need 2n values to compute C of x, that is the output, because C of x is equal to A of x into B of x. Okay, this value has to be found out, this value has to be found out, they have to be multiplied, only then I will get the answer. If you see, ax is a polynomial, a0 plus a1 x square plus a1x, a2x square, so on. Okay, until an minus 1. Okay, that is our priority. Again, bx is a polynomial, b0 to bn minus 1, a0 to an minus 1. How many values? b0 to bn minus 1. How many values? So here n values have to be found out. Here n values have to be found out. So to solve for C, I need at least 2n values. N values of A and n values of the polynomial B. Okay. Now, if I can reduce this value so that, because if I calculate for n here, again I calculate for n here and I multiply them, the time will again become n square. So, at this point, I need something that interrelates A and B. Okay. So now instead of 2n values, if I can find 2n values had to be calculated 2 times, n and n. Now if I can find 2n values where A and B are related, if I can find these 2n values, then I can apply recursion. Okay, because the same 2n values I will apply for A, the same 2n values I will apply for B. Okay, so if you see 2n such values can be found out, let us take 2 polynomials. Okay. Yes. Given these 2 polynomials, which are the values that can solve A and B? What are the values that can solve A and B? The answer is definitely roots of unity. Okay, so if I can find the roots of unity for this polynomial and this polynomial, then I can solve this polynomial and this polynomial using those n roots or k roots. Okay, so therefore, in order to solve the problem of A and B, now we are going to find the 2, because we needed 2n values. We needed 2n values to compute A, for 2n values of A and 2n values of B, then we will get the value of C. But now we have found 2n values through the roots of unity, so that the same values can be applied on A and the same values can be applied on B. Okay, so yes, now this roots of unity is the solution to our problem. Okay, we will again start from here in the next class. Okay, and we will start from the concept of roots of unity, and we will see how the solution of divide and conquer can be formed. Okay, I have an exam duty to take. Yes, until now, any doubts? I know this is a difficult topic, but yes, until now, are you able to understand how we divided the problem into arrays? How we divided the signal? From the signal we reached into the arrays. Could you visualize that?
Yes, sir.
Yes,
Yes.
sir.
Again, in the next class, we will discuss from here itself because this topic requires 2 classes at least. I'll try to complete it in the next class, and in the next class itself, we will start the concept of memoization. Okay. So until then, I am sharing the link for today's quiz. Just take the quiz and let me know if it is working or not. 2 times I pasted it, in fact.
Yes, sir.
Yes.
Working.
Any one of them will work. Okay. So try to answer the quiz, and we will meet in the next class where we'll discuss another topic and complete this and discuss another topic. Okay. Until then, thank you for your time and thank you for your patience.
going to change little.